So now question 2B, test 3, 2019. And in this question here, you're told that there's a quantity of electric charge deposits 0.732 grams of silver from a solution of silver nitrate. I'm going to stop right there with the question. Let's write that down, see what's going on. So you know you have a solution of silver nitrate. And we know from first semester, this breaks down nicely in solution, or it dissolves nicely in solution into silver plus and nitrate ions. And then you're told that you're depositing silver. So you know that the reaction that is occurring is going to be silver plus going to silver. And we're making 0.732 grams of solid silver. So we can balance this reaction just by adding an electron on there like that. You're told it takes a certain quantity of charge, and we don't know what that is. Now the next part says when you use that same quantity of charge pass through a solution of a gold salt, you get a certain mass of gold. So you're just told that it's a gold salt. So you don't know what that salt is. You don't know the oxidation state of it. So we can call it gold and plus. We know it's a salt, so we know that it's broken down into its ion in solution. And we know that we are depositing pure gold. And you end up depositing 0.446 grams of gold. So to balance the rest of this equation, we know that we're going to need n electrons, whatever that is. So now from here, we can either figure out this charge or figure out how many electrons are being passed through here. It's going to be the exact same number of electrons that we have to pass through here to get that mass. So starting from up here, we can find our moles of silver, and then from there, our moles of electrons. So if we do want to find moles of electrons, let's try, let's say 0.732 grams, and you're dividing by the molecular weight of silver, which is 107.87 grams per mole. And then do your conversion factor. In this case here, it's really nice and easy. 1 electron for every 1 silver. What's going on? Right, silver like that. So just exactly the same. 6.79 times 10 to the minus 3 moles of electrons are being passed. So if it's the same charge, same moles of electrons going through. Now we can figure out how many moles of gold this corresponds to. So then we know how many electrons total we have, so we can find that ratio right there. So this was for the silver. Now if we look at the gold one, we had 0.446 grams, and that oxidation state is, molecular weight is 196.97 grams per mole. So when you work this out, you have 2.26 times 10 to the minus 3 moles of gold. So now to find out that ratio, we know this is the number of electrons you have, this is how much gold you have. You can find that ratio, and here they're both times 10 to the minus 3, so we can just go 6.79 divided by 2.6, and this is to find n, and that equals about 3. So that means that we actually have gold in the 3+ oxidation state.